Hello everyone, my name is Hisham. I'm the owner of Clemson Aeronautics, where we make the riveting and dimpling systems. Today is the first video of a series of videos with a title, Building Essentials. The reason I am doing this series of videos is because of what I see on the internet and YouTube and Vans Air Force. I see a little bit of lack of knowledge from people that are in their building process of their airplanes or just getting started. The type of questions they ask and so forth indicate that they need to know a little bit more. Also, when I see somebody has been building his airplane for 6, 7 years, 8 years, 9 years, and it is not that something happened in their life that made them stop for a while. No, they might take like a couple months break and get back into it, sometimes a year break and get back to it. Yet they are taking so long. I don't see a reason for that except that they are doing things the wrong way. That's why it's taking them so long. So I thought I would start this series and talk about the essential things in building an aircraft, so you can do a better job. That is the main point, guys, is to do a better job in building your airplane. So not only it would be safe, it would look really nice too. Because imagine if you are building your airplane and then the surfaces are all wavy and everything, and you can't hide that with paint. So I visited a Builder's Assist Center in Georgia, one of the most famous one. And the gentleman there that was kind of giving me the tour, he is the manager of the place, showed me an RV-14 that looked horrible. Looked like somebody riveted that with a hammer. And it's just like, I thought, man, if they have supervised this gentleman building his airplane there and this is the outcome, this is really bad. But he explained to me later on that this gentleman started building his airplane at home, and this is the result, and then he got frustrated and he brought it to them so he can finish it over there. So I asked him, would paint hide that? And he said no. But instead of just totaling the airplane, he thought he would just finish it up and fly it himself. So there is some people out there that they are just don't have the essential knowledge to do this job, and they are not seeking help, yet they are still working on their airplanes the wrong way. I thought I would jump in and give my 2 cents worth, since we are one community. The aviation community are very small. We are few and far in between. So I will try my best to explain some things that would make it easier for you to do the job that you're doing right now, which is building the aircraft. Now, the biggest thing in building the aircraft is riveting the parts together. To rivet two parts together, you have to have holes, and in the case of a universal head type rivet, you just need the holes, but nice clean holes. In the case of a countersunk rivet, you need an accurately dimpled skin on both surfaces. So now there is three things we have to deal with: holes and dimpling and riveting. Today's video we're going to talk about hole preparations. Why is it so important to discuss this in such a minute details? Number one, of course, in aviation is safety. Number two, the whole preparations is really gonna determine the shape of the airplane. Some people think that it's just a hole and you're gonna drive the rivet. No, it's not. This is the first step of riveting, and the outcome from the whole preparation is gonna have an effect on how the surface of the aircraft, whether it's a flight control or the airframe itself, will look like. And so if you want to get a surface that looks like this, and I'm trying to make it shine so you guys can see how nice this surface is that I built myself. And this is kind of our lab here. This is our lab that we try the tools on, and building this is what we're doing. We're trying to figure out what tools you guys need out there so we can make these tools and sell them to you. So if there is a tool or a method that doesn't work, we have to find out and correct the problem. Now, the other issue, we talk about safety, about looks. Now we talk about time. What if there is something that you're doing that's consuming more time, that's going to affect how long it's going to take you to build the aircraft? I was told that the RV-14, for instance, have about over 14,000 rivets. Now, 14,000 rivets, that means that at least we have about 28,000 holes to deal with, because each rivet will take at least 2 holes. When you have 28,000 holes, you have to deburr them from both sides. That's 56,000 deburring operations on the airplane. That is a huge number. So now, each second it takes you longer to deburr a hole, it translates into 15.5 hours extra work that you have to do while you're building the airplane. You can multiply that. 1 second times 56,000 deburring operation. So if you use a really bad drill and you have to do this, and it takes you 2 seconds longer or 3 seconds longer or 5 seconds longer to clean up the result of a bad drill, that adds up pretty quickly. If it takes 5 seconds, multiply that by 15.5 hours. This is a lot. Solution: very sharp, correct kind drill, and a very good sharp carbide reamer. Now, what is going to help us save this 3 months is using the correct tools. Also, the correct tools will give you a good size hole. Good size hole means the rivet will be set perfectly like it was intended to. And for those of you who have already started on your build, you will notice that when you are setting any universal head rivet, the one with the dome, you tend to do less mistakes. You tend to do less of drilling out rivets than the countersunk or flathead rivet. And there is a reason for that. Most people don't know. The universal head rivet, you don't dimple. So the size of the hole itself, it is just tiny more than the size of the rivet. For instance, let's take the number 4 rivet, for instance. You are probably given a hole that's either a 1/8 and you have to final drill it to number 30, which is 0.128, which is just 3/1000 over the 1/8. Or if you're lucky, and we are all lucky because Van now starting to give us kits that already punched to size, and you don't have to do anything to it. They don't even mention deburring, but it is our job to see if there is a burr on the hole to remove it, and usually if it is, it's very, very light. So the rivet itself is 0.125 and the hole is 0.128. Whether it was already punched that way or we created that hole, it is very tight. So when you put two pieces of materials together and you put a rivet in between, the wall of the hole is holding the rivet straight up. So it is difficult for it to tip. That's why you don't drill out too many of the universal head type rivets. In the case of the flathead rivet, most of us dimple it from let's say in the instant, because flathead rivets, the number 3, a lot of it, or even most of it, is number 3 rivet. It is 0.098 before you dimple. Then you dimple it. Dimpling operation opens up the hole to 0.106 or 0.107. Now the rivet is 0.093 and a half. So the difference is huge. Now the rivet is swimming inside that dimple. So there is no support for it while you are squeezing the rivet. There is no support holding it straight up for you. So it is so easy to tip that rivet. The rivet can tip if you're not perfectly perpendicular on it. It could tip. That costs you time that you don't need to be wasting because you have a lot of rivets to do. Now, there is another aspect of that you have to look at, and it is really important when it comes to safety. Now, if the rivet is 0.093.5 and it's intended to go in a hole that is 0.098, so when you squeeze that rivet, it's going to expand. The whole shaft of the rivet will expand all the way to the head till it meets the wall. When it meets the wall in the area of the skin, it will expand just a little bit, maybe another couple of thousand. Then it stops expanding, then it starts forming the shop head. This shop head is what's going to hold the two pieces of material together. Now, if the hole is not 0.098 and it's much larger than that, then you have to squeeze the rivet much more before you reach the wall of a 0.107, and then expand that just a little bit more. Now you are at 0.109 or 0.11 before you start forming the shop head that is going to hold the pieces together. So you squeeze it. You require a longer rivet because you wasted a lot of it inside that hole. Then when you check the diameter with a go no go gauge, you're checking it. I mean, if a number 3 rivet shop head is the diameter multiplied by 1.5, that's about 0.140. Now, if the shank inside, the shank of the rivet inside is at 0.110 and the head goes out to 0.140, there is only 30 thousandths bigger. The head, the shop head, is only 30 thousandths bigger than the shank of the rivet. That means the part that's hanging out, that's holding the material, is 15 thousandths on each side, 0.015 only. That is what's holding it. So safety wise, I don't know what the FAA think about that. I know from experience that this is the case. That's why I use a reamer that is much smaller than a number 40 reamer. Then when I dimple my material, the hole size is right around 0.101. So again, you have to make a decision, your decision on that. It's not my decision. But what I have done with my airplane, I used a 0.095 reamer. I think a 0.096 would work well too. And hopefully that will give me around 20 thousandths on each side on the shop head instead of 15. Safety wise, it will grip better and it will give me better results. Deburring tools. This tool is the best kind that you can use for deburring. See that kind of tool that have a hole in the side? It's called a single edge. And what happened that the back side of this holds it perfectly on center when you are deburring your hole. Now, if you use a bad drill and you're not perfectly perpendicular, and it will make a huge burr, and it could be heavy on one side than the other, heavier burr on one side than the other. Then you put this deburring tool in there and you try to deburr the hole. What happened is that the burr is so huge that single edge can't take it all in one cut. So what happens, it jumps a little bit, take the top of the burr off, then it lays down again. Then when it comes back the second time, it takes some more, and the third time takes some more. In the meantime, the light burr area, you're digging into it more. So now the hole is, you know, lopsided. It's you're taking too much skin from one side and you had it now level and clean on the other side. That's another issue. You're making the skin weaker on one side than the other. And you have to keep that into consideration. And that's also an issue when you are dimpling. If the skin, if the hole, you're dimpling a hole, and the material is weaker on one side than the other, well, that other side is going to give a little bit. So that dimple is not going to be on center. So bad tools will cost you in time a lot, and probably in money. How is that? Bad holes, bad rivets, bad dimples. I mean, when you're trying to rivet, the hole is big and the rivet tips. You have to drill it out. Now you're spending a lot more time than you should. Just in case, if somebody had not watched my previous videos, that I mentioned the tool Easy Burr. I'm gonna put a picture on here right now. This tool, what it does, some people use it to deburr their parts with. It is very dangerous, because what happens, this tool have this blade on it that's sharp on both sides. So somebody puts in a drill and goes in a hole, so while he's going in, the front edge of that blade chamfers the hole or deburrs the hole, and then goes to the other side. He's continued turning the drill. When he pulls it out of the hole, it chamfers the other side. And what happens, the drill continues to turn while it's going through the hole, and it shaves off 2/4,000 of an inch off the wall of the hole, makes it bigger by that much. This gets really critical, and I have seen people talk about that on Vans Air Force. This tool is made for like a solid piece or something, not very thin sheet metal. And what happened, that this gentleman had final drilled his skins and his ribs, then used this tool to deburr his skins and his ribs. Then when he put them together and he put a cleco, the hole, and he dimpled it. Okay, so dimple made the hole much larger now because he started out with a hole that is so huge because of that tool shaving off so much material. So when he put the cleco in, it just fell out. It wouldn't hold the parts because the hole was so big. So, and he mentioned that it was like 114,000, 0.114 or 0.115, something like that. My advice, don't use that tool. Yeah, it is easy, and it will make your 50,000 or 56,000 deburring operation into 28,000, but at the same time, you're ruining your airplane. The rivets is not holding except by very, very thin area. Holding the airplane together with that is very dangerous. I mean, you'd be asking for it. Kind of like, you guys seen the oops rivets, which is pretty much like a number 4 rivet, but it have a number 3 rivet head. So it's there for just looks. It's just a thin area that's holding the manufacturer side is such a tiny little area, and it's just made to basically fill in the hole. So it looks like a normal airplane, but you don't know what's happening inside. So be careful with that tool, and as I mentioned before, that tool have no place in my shop, period. I might use it on steel in my manufacturing part of it on steel, but for airplanes, I don't think this tool is appropriate at all, so be careful with that. What is the end result of all of this? We need to get to the point where we are going to do quality work and save time. Split point drills, so you can have a fairly clean hole when you match drill. Carbide reamer that is very sharp, good quality carbide reamer to final drill the holes. When you're match drilling, use a fraction drill to the size. So if you're match drilling to a number 4 rivet, for instance, use a 1/8 drill. That's the fraction drill. After you finish that, go in with a number 30 reamer. Same thing with the number 40. Use a 3/32 drill to do the match drilling. Then go in there with the size reamer that you're gonna pick. Please try to use a smaller reamer than a number 40, because I feel like guys, there's one thing that I want to warn you about, and you are going to hear that when you ask some of this tough questions to, well, I'm not gonna say to who, but when you ask some questions, you gotta reply something like, well, there is thousands of airplanes that was built that way and they are flying and they have no problems. I heard that answer a couple of times before. And let me tell you, I don't want to be the first one that would, God forbid, have an accident because of that issue that I was asking about, where the FAA is going to put an advisory. It says, hey, people, we know that there is 10,000 airplanes out there that was built that way, and they are still flying. But we have one that showed that this is an issue, and we don't want you to do that anymore. Guys, there is... There's airplanes out there that's been flying for 20 and 30 and 40 years, that was built, designed and built 40 years ago, that there is ADs that's coming out today saying, watch out for this thing because it failed, and it's just starting to fail now. We saw it on 3 airplanes. So everybody that have this type of airplane, stop flying, take it to an AMP or an IA or a center or something to check that thing because it compromises safety. Well, I don't want to be a statistic, or I don't want to be the one that would incur that. So this answer of there is thousands of airplanes flying out there that was built that way is not a good answer for me. I'm dealing with numbers. I want an answer to this. How come there is a rivet that is 3/32 rivet that after I finish dimpling, it sits there and swims inside that dimple? So if you are concerned about that, it is up to you to find an answer and take an action. For me, my action was, I know that dimpling is going to make the hole bigger, and this is not what I want. So I am going to use a 0.95 or a 0.96 reamer to ream that hole. So when I dimple it, it's up to like 0.101 or 0.102, so it's not so huge. And you guys need to experiment with that at home. Get a piece of scrap aluminum, drill a hole in it, final drill it to a number 40, then dimple it. It is so easy. Get your set of calipers and check the dimensions. If you don't like what you see, please do something about it. To give you guys a for instance from what I did, you guys recognize this. Here there is a 1/4 inch hole. I think that hole, if memory serves me, it was like a 1/8 hole or something. And it said to match drill, did not exist in one surface, but it was 1/8 on another surface, and it told us to match drill it to 1/4 inch. What I did to feel comfortable, because this is obviously the hole that I'm gonna put a bolt in to hold that control surface to my airframe. So I wanted a nice clean hole. So what I done is I got a drill that is less than a 1/4 inch, match drilled that. So now in both surfaces it is less than 1/4 inch, and got myself a 1/4 inch reamer and reamed it. Then I deburred it. Now when I put a bolt in here to hold this thing down, that is going to be exposed to 220 miles an hour, and I hope the airplane will go that fast. I think it should. 220 miles an hour. It stays with me. I want it to stay bolted to the airplane. So if there is a small crack in there, it will be dangerous. So I made sure that I reamed it so I have nice smooth surface, deburred it, and finished my part. So this way I feel comfortable that hopefully the vertical stabilizer will stay with my airplane at all times. And now I think it's a good time to talk about the quality of the hull itself. Guys, remember the skin have thickness. This is the skin of the airplane, and you drill the hole and you are deburring it. When you're using this tool to deburr it, you're doing the outer surface of the skin. You're just taking a little bit of the corner and then a little bit of the corner on the bottom. The middle, you're not doing anything with it. The middle stays in the shape that you created when you use that drill to drill it, or reamer to ream it. So if the quality of the hole, the wall of the hole inside is not good, you're not going to be able to change that unless you re-drill it or re-ream it. So the quality of the tool means everything. And now it brings us to the point of the cracks. Cracks form in the wall of the hole. And cracks, what happens is this stress from these two sides trying to separate is totally concentrated on that point at the end of the crack. That's why it keeps on growing. Solution from our books, airframe manual from AMP course from college, and also from advisory circle. That's by the FAA, guys, and you can download that from the FAA website. If you don't know how, please let me know or email me. I'll email you back the link to that book. It's free. When this book, just to let you know, guys, what this book is, if a manufacturer of an airplane doesn't have a repair procedure for something, especially on the airframe stuff, and an AMP or an IA is doing a repair to an aircraft, he have to resort to something and to tell the FAA, I repaired this according to something. That something is this book. You can Google AC43.13 and you will find it, or AC43.13, and it's on the FAA website. You can download it. You're not gonna need it, but it's a good idea to have it, so when you're working on the airframe, you can get an idea about how things are done. So, solution for cracks is stop drilling. That is what's mentioned in both books. Stop drilling. When you stop drill a crack, you're basically taking the point out, the point of concentration of that load, and you're dividing it by the entire surface right here. So each part of the surface is taking a fraction of that load so it can hold, and the crack won't spread. So now, if the wall of the hole from the inside have small crack, minute cracks that you can't even see with your eye, you have to have a microscope to see it. This is where cracks start, because the load concentrates on that. At the beginning it's a small load, then it gets bigger, then it gets bigger, then it gets bigger. Guys, remember, as soon as you start your engine, vibration starts. Not to mention fly. It's just as soon as you start your engine. Then you go flying. And the whole airplane is doing this number. Maybe at the beginning of a crack like this, it's not gonna get affected small vibration like that. Then it gets bigger, then it gets bigger, and so on. Even jet engines produce high frequency vibrations. Most people can't feel it, but it is very stressful for the airframe of the aircraft. So watch out. Clean holes, answer, very sharp drills and reamers. Folks, again, please be careful with hole preparations. Again, split point drill, carbide reamer, and pretty soon, I didn't want to talk about this, but I guess it's just this time is as good as any. I visited a friend of mine that have a tool company. He sells tools to big manufacturers. So he goes into a factory, he's got the contract to tool them up for their machines and so forth, and he goes to they tell him come in and tool this project right here. So he would get all the drills and reamers and cutters and all that stuff for them, and he know the consumption per week, and he makes sure he have that in stock, and he supplies them every week with the necessary quantity to stay in stock for them so the production doesn't stop. So he sells in large quantities. So I went to him and I twisted his arms and I told him he have to supply me with the drills for us. And I'm saying us is me and you. And what's gonna happen, I am gonna get these drills and reamers from him. I'm gonna keep them in stock and we're gonna sell them on our website. Is this to make money? Let me tell you, I ain't gonna get rich selling you drills. This is just, there is no money into it. I mean, not for me, unless everybody calls in and asks for about 100 drills or something like that. I am not going to make money. I am doing this as a favor to my customers to have this type of drill and this type of reamer available that he can just simply order from my website, get the order, I'll put it in the envelope and send it to them, so you can have that available at hand. So this will be available on our website very soon, perhaps maybe not next week, but the week after that. I'm working on the website. The website, again, you can buy our machines and the rib dimpling option on it. You can buy it now. So we are working on the construction of the website, and we'll have that. We will have the 3M wheels. These are like $90-something each. Now, I managed to also get a good deal on that, and I will save you money on that. Scotch-Brite pad 7447. You will get that cheaper than anywhere else also. You will also get our yokes. 3 types of yokes that I mentioned in the last video. A 3-inch with the hole, and a longeron yoke, and a 4-inch no hole yoke. So all these hopefully very soon will be available to purchase on our website. Guys, take care about the holes. Nice clean hole, sharp tools. From the first time your deburring operation, cut the time in half and finish your build so you can fly your airplane. Thank you very much for watching, and we'll see you next time.